video of the Power Wheels upgrade solution that preserves the functions of the original 12V music, lights, and horn. Hello, everyone. Today, I'm going to explain a Power Wheels upgrade solution that can preserve the functions of the original 12V lights, horn, Bluetooth, etc. After upgrading with this solution, you can directly use an 18V/20V DeWALT tool battery to enhance the vehicle's power and speed, and also achieve variable speed control, braking function, soft start function, and low battery voltage protection function. At the same time, the functions of the lights, horn, Bluetooth, etc. in the original 12V system can be retained. The DW-LVP-009 kit product includes most of the accessories required for this solution. If you purchase the PWM03-00J kit product, please use your own battery adapter to replace this adapter. A regular adapter only has a battery voltage output and no 12V DC-DC output. Our adapter includes both battery voltage output and 12V voltage output. If you use other adapters, you need to add an additional 12V DC-DC module. Next, let's explain the upgrade principle in detail. First of all, before modifying a vehicle, it is necessary to have a clear understanding of the wiring layout of the original vehicle. Since the internal wiring structure and accessories of each vehicle are different, we should first master the wiring principle of the original vehicle and then make the modifications. I will take the modification of this vehicle as an example. This is the circuit diagram of the original vehicle. We need to upgrade to this new circuit diagram. Our upgrade idea is as follows. After passing through our adapter, the DeWALT battery outputs two voltage circuits. One is the battery voltage and the other is 12V. The 12V voltage is directly connected to the original 12V battery cable. Remove the original battery. The battery voltage passes through the fuse, the brake switch, the PWM module, and the gear shifter, and finally reaches the motor. Since the original vehicle operates on 12V and now we're going to use a 20V DeWALT tool battery, the original power-related accessories need to be replaced. Here, we need to replace the original 2-pin brake pedal with a 3-pin pedal. Also, replace the 3-pin gear shifter that controls gear shifting through the relay inside the original vehicle controller with a 6-pin independent gear shifter. The 6-pin independent gear shifter can achieve forward, neutral, and reverse functions. This 6-pin gear shifter is equivalent to a double throw switch. Looking at the gear shifter part in this diagram, let's explain the following principle. When the gear shifter switch is toggled to the right, the current flows from PWM M+ to pin 4 of the gear shifter, then through the connecting wire to pin 3 of the gear shifter. After that, it flows from pin 2 of the gear shifter to motor M+. Next, it passes through motor M-, shifter pins 5, 6, and 1, and finally returns to PWM M-. When the switch is toggled to the left, the current path is from PWM M+ through shifter pins 4 and 5 to the motor, then to shifter pins 2 and 1. And finally to PWM M-. When the switch is in the middle position, cut off, the neutral gear is achieved. Looking at this diagram, we need to make adjustments to the accessories inside these blue boxes. The first one is to disconnect the rear wheel motor. Later, it will be incorporated into the new motor power circuit. The second one is the main switch. Disconnect the main switch and directly connect the wires at the same time. The main switch will be replaced with the upgraded main switch later. The third one is the pedal. Disconnect the pedal wires and remove the pedal. Later, a new pedal will be installed and connected to the motor power circuit. The fourth one is the gear shifter. Disconnect the gear shifter wires and remove the gear shifter. Later, a new gear shifter will be installed and connected to the motor power circuit. For the specific connection principle after the upgrade, please refer to this diagram. Looking at the circuit diagram after the upgrade, a multifunctional battery adapter is used to connect to the power supply, with two output paths for separate connections. I'll start the explanation in the order of the current flowing from the battery to the load. The first is the power circuit from the battery voltage to the motor. The B+ port of the battery voltage is connected to the fuse. The output of the fuse is connected to the brake pedal. The principle of the brake is as follows. When the brake pedal is pressed, pins 2 and 3 of the brake pedal are disconnected, while pins 1 and 2 are connected. This cuts off the power supply to the PWM module, and the M+ and M of the motor are short-circuited through the brake resistor, thus providing braking force. When the pedal is not pressed, pins 2 and 3 are connected. At this time, the current passes through pin 2 and flows to the PWM P+ port. After being modulated by the PWM module, the current flows from the PWM M+ port to the gear shifter and then to the M+ of the motor. Finally, the current passes through the M of the motor, goes through the gear shifter, and returns to the PWM M-. After being modulated by the PWM module, the current flows from the PWM P through the main switch to the G port of the adapter. The current then flows to the negative pole of the battery along this path. The second is the original vehicle's 12V voltage circuit. The 12V output port is connected to the original vehicle's wire that was connected to the positive pole of the battery. The original vehicle's wire that was connected to the negative pole of the battery is connected to the main switch or the PWM-P port. The current passes through the switch and then returns to the adapter's G port to form a closed loop. If you don't need the 12V voltage, or if you have your own adapter, you can skip this step. It's equivalent to the adapter providing 12V voltage to replace the original vehicle's battery. In this way, all the original vehicle's 12V related modules can work normally. Note that the internal 12V DC-DC of this adapter only supports a maximum of 2.5A. Usually, it's sufficient for the original vehicle's 12V modules and leaves a certain margin. If you need to add other 12V modules such as lights, you need to pay attention to calculating the power. The overall current cannot exceed this rated current. After connecting the entire circuit in this order, insert the battery into the adapter, operate the startup module, and then set the required PWM value and battery adapter value to use it normally. Steps for upgrading the wiring. Taking the modification of this vehicle as an example, the actual modification operation for the vehicle is carried out in 3 steps. Step 1. First, connect the new shifter's own wiring in series and follow the corresponding physical objects and schematics mentioned above. For wiring, I use the following tools and cables. The shifter needs 4 cables of corresponding lengths to connect to the PWM module and the motor. The connection between the shifter pins also requires 2 short cables in series. After these 6 wires are ready, we start to connect them. The 3 pins below the shifter correspond to 1, 2, and 3 in the figure. The 3 pins above correspond to 4, 5, and 6 in the figure. First, connect the 2 middle pins, which are pins 2 and 5 in the figure, to a long wire to the motor and fix them with heat shrink tubing. Then connect the 2 pins 3 and 4 in the figure in series and connect a long line to PWM at the 4th pin and fix the pins with heat shrink tubes. Finally, connect the 2 pins 1 and 6 in the figure in series and connect a long line to PWM at the 1st pin and fix the pins with heat shrink tubes. If you don't have heat shrink tubes, you must use other insulating materials instead to avoid contact short circuits. The entire shifter is connected in series like this. Step 2. Refer to the original vehicle's schematic diagram and disconnect all the wiring of the original vehicle's paddle, main switch, gear shifter, and rear wheel motor. I'll start with the paddle. Disconnect the connecting wires and remove it. Disconnect the connecting wires of the main switch and then directly reconnect them. Disconnect the connecting wires of the gear shifter and remove it. Cut the wires of the rear wheel motor here. Finally, install the newly connected gear shifter. Step 3. Start wiring. Begin to connect the wires according to the schematic diagram. Personally, I recommend installing the PWM and the adapter outside the vehicle. This will facilitate daily button operations and battery replacement, and also ensure better heat dissipation. However, be careful to prevent these accessories from coming into contact with water to avoid short circuits and damage to the accessories. Upgrade of the motor power circuit. Connect all the accessories between the battery adapter and the PWM in series according to the corresponding connection diagram. Here, you must pay attention to the connection method of the pedal pins and never connect them incorrectly. You need to use a multimeter to measure the two states of the pedal, pressed and not pressed, to determine the positions of pins 1, 2, and 3 of the pedal. After the detection, connect the other end of the fuse to pin 3 of the pedal. Connect pin 2 to the P+ port of the PWM. Connect pin 1 to the brake resistor, and finally connect the brake resistor to the PWM port. In this way, the connection between the battery adapter and the PWM is completed. Note that the positive and negative poles cannot be connected incorrectly. Then, connect all the accessories between the PWM module and the motor in series according to the corresponding connection diagram. Connect the two incoming wires reserved on the gear shifter to the M+ and M ports of the PWM respectively. After the connection, fix the screws tightly. Connect the other two output wires of the gear shifter to the motor. In this way, the connection between the PWM and the motor is completed. Finally, install the variable speed pedal. For this vehicle, we will install it on the left side. This is a pre-drilled hole from my previous modification, so we can directly install the pedal. After the installation, insert the connecting wire of the variable speed pedal into the corresponding P, G, and +5 ports of the PWM. The wiring of the motor power circuit is now completely connected. Connection of the original vehicle's 12V circuit. Remove the motor wire buckle on the original vehicle module, and then disconnect the positive and negative connection wires between the module and the battery. Next, connect the second circuit. Connect the 12V output port to the wire that was originally connected to the positive pole of the battery in the vehicle. Connect the wire that was originally connected to the negative pole of the battery in the vehicle to the PWM port. The current is connected to the switch through the connecting wire and finally returns to the adapter's G port to form a closed loop. If you don't need the 12V voltage, or if you have your own adapter, you can skip this step. Now that the wiring is completed, check it again according to the schematic diagram to confirm that all connections are correct. After confirmation, you can install the battery and start debugging and using it. Connect the battery and press the on button of the adapter to start the module. The screen of the adapter will light up. Then turn on the main switch. At this time, the PWM indicator light will turn on, indicating that it starts to work properly. Now, let's set the parameters of the PWM and the adapter. PWM settings. Speed setting. Set the speed, soft start time, voltage calibration, and low voltage protection value. First, set the speed. Move the switch to the P position. The number on the screen represents the current setting percentage. In this mode, the actual speed is obtained by subtracting the set value from 100%. The final value is the actual speed. For example, if we want the maximum output speed to be 90% of the full speed, we need to set the PWM to 10 because PWM max equals 100 PWM setting value. If we want to output 100% speed, we need to set it to 0. So the smaller the set P value, the greater the maximum driving speed. However, note that if the motor is a 12V or even lower 6V motor, do not set the P value too small, as excessive speed and power may burn out the motor. To set the value, when the switch is in the P position, press the up or down key. The number on the screen will start to flash. Short, press the up or down key again to adjust the p-value. For this vehicle, I set it to 0. After setting, press the OK key to save the setting. Soft start time setting. Move the switch to the T position. The number on the screen represents the current soft start time. Short, press the up or down key. The number on the screen will flash. Short, press the up or down key again to adjust the soft start time. The setting range is from 1 to 30 seconds, and the default is 10 seconds. If you want a gentler start, you can set a larger value, which will reduce the impact on the motor and the gear shifter. If you want a quicker start, set a smaller value. Test and set it according to your specific needs. Currently, I set it to 10 seconds. Make sure to press the OK key to save the setting. Note, the minimum value is 0.1 seconds. Do not set it to 0, or the PWM will not output. Voltage calibration setting. Move the switch to the V position. The number on the screen represents the current battery voltage. Short, press the up or down key. The currently set low voltage protection value will flash on the screen. At this time, press the up and down keys simultaneously. The screen will display CRL. Press the up or down key again. The set voltage value will flash on the screen. Press the up or down key to adjust the value to the correct battery voltage measured by multimeter. Press the OK key. The screen will display 0, indicating successful setting. Press the OK key again to save and exit. Low voltage protection V value setting. Move the switch to the V position. The number on the screen represents the current battery voltage. Short, press the up or down key. The number on the screen will flash, showing the currently set low voltage protection value. Press the up or down key again to adjust the value. Long, pressing will adjust it faster. I'm using a 20V DeWALT tool battery. Usually, its minimum protection voltage is 16.5V, so we set it to 16.5V here. Short, press the OK key to confirm and save the setting. Note that after the setting takes effect, the LED will stop flashing and switch to displaying the current battery voltage. When the battery voltage is lower than 16.5V, the LED will display a low, and the PWM will stop outputting. However, note that although the PWM has low voltage protection to stop its output, which can prevent the battery from discharging below the minimum voltage value during long-term use by a child and causing battery damage, the PWM's own chip will still work and consume a small amount of power. So, when the vehicle is not in use, turn off the main power switch or remove the battery. Otherwise, the battery will still be damaged after weeks or months. Of course, I'm using this adapter with low voltage protection. If the 20V DeWALT battery is normal and not aged, you don't need to set it again and can directly use the initial default values. If the battery has other voltages or is aged, you need to reset the high and low voltage protection values. When a voltage is lower than the set low threshold of the adapter, the battery will stop outputting voltage to protect the battery from overuse. However, the battery itself will self-discharge. For batteries that are not used for a long time, it is recommended to charge them periodically to maintain battery activity. I'm using a normal 20V DeWALT battery, so I don't need to set it separately. You can scan the QR code to view the specific setting method of the adapter. Now, organize and fix the wires, install the original vehicle seat, and the vehicle can be used normally. Let's take a look at the effect after the upgrade and modification in the video.